Okay, everyone. Last week we just go over the midterm exam. And again, if you have any question, please let me know. Please let me know. And again, in the future, I try to teach you some basic ways. Meanwhile, I will let you know some useful tools because you can get the answer just a few clicks. Again, let me emphasize it again. Please do not learn the fast way first. Please learn the traditional way first. You need to understand the rules, why we do this kind of calculation, why we need to cannot lose some steps because they are critical for calculation. Okay, so today we will move to chapter 7.2. 7.2. All right. And okay. Hi, Jerry. Could you take a look? Jerry, see my mouse on the tablet is working now. Is it? How can I say that? It was annoying for me. Okay. Okay, and now let's move to this chapter 7.2. One sample proportion test. Okay, there are many different parameters that you can test. There is a test for the mean, such as introduced the z-test, and there is also a test for the population. Oh, sorry. For the population P, okay. This is where you might be curious if the proportion of the students who smoke at your school is lower than the proportion in your area, or which proportion is correct, okay. Or you could question if the proportion of accidents caused by teenager drivers who do not have a driver's education class is more than the national proportion. Okay. Then to test a population proportion, there are a few things that need to be identified first. Usually, Greek letters are used for parameters and Latin letters for statistics. Okay, again, Greek letters for parameters and Latin, and sure, for American accent, it can be read as Latin. I don't like this kind of American accent. I prefer to read as European accent. Latin is better, but in American accent, Latin. Okay, the Latin letters for statistics. While talking about proportions, it makes sense to use P, the lowercase and italic P for proportion. The Greek letter P is pi, but it's too confusing to use. Instead, it's better to use P for the population proportion. That means the different symbol is needed for the simple proportion. The convention is here, P hat, okay, a head above the P hat. This way, you know that P is the population proportion, and the P hat, wearing a hat, is the sample proportion related to it. Okay. And now, now proportion tests are about looking for the percentage of individuals who have a particular attribute. You are really looking for the number of successes that happen, that a proportion test. Okay, let's move here. Hypothesis test for one population proportion. One proportion test. First, state a random variable and the parameter in words X, then the X to be the number of successes. Here should be L. L is proportion of successes. Okay, state the non-hypothesis and alternative hypothesis and the level of significance. H non proportion P equals P0, where P is the unknown proportion, and alternative hypothesis P is smaller than P0, or P is greater than P0, or P is not equal to P0. Okay. Also, state your alpha level. Generally should be 0.05. It means 5%. State and check the assumption if the hypothesis test a simple random variable of the size n is taken. The conditions for the binomial distribution are satisfied. To determine the sampling distribution of here pH, you need to show that n times p is greater or equal to 5, and nq that is greater or equal to 5, where q is equal to 1 minus p. If this requirement is true, the sampling distribution of p hat is well approximated by the normal curve. Okay. Find the statistic and test the statistic and p-value. Here, the sample proportion p hat is equal to x divided by n. And that is the number of successes and number divided by the number of trials. And the test the statistic z score, the z is close to z score, is p hat minus p divided by the square root of this one. Okay, let's check here. I know you may confuse with this. We can watch this. Okay, maybe this one. Okay. The example hypothesis for one proportion using formula. Okay. A concern was raised in Australia that percentage of death of Aboriginal prisoner was higher than the percentage of death of non-Aboriginal prisoners, which 0.27%. Example of 6 years from the year of 1990 through 1995 of the data was collected, and it was found that out of 14,495 Aboriginal prisoners, 51 died, and do the data provide enough evidence to show the proportion of deaths of this kind of prisoner is more than 0.27%. Okay, let's check here. Okay, the X to be the number of original prisoner who died. P, the proportion of original prisoner who died. Then the hypothesis H non proportion is equal to 0.0027. Alternative hypothesis proportion is greater than 0.0027, and set the alpha level is 0.05. And in this case, the P is equal to 0.0027, N is 495. Thus, NP, the N times P, greater than 5. And the NQ, 1 minus 0.0027 is also greater than 5. So the sampling distribution of pH is a normal distribution. And then the sample proportion X equals 51, the death, and 14,495, the total number. And after calculation, p hat X divided by N close to 0.003518. Then test the statistic. Z, pH 0.003518 minus 0027 divided by this. Sure, P is the original proportion. Q, 1 minus 0.0027 divided by 14,495, and the answer close to 1.8979. Okay, then calculate the p-value. The p-value is about 0.029. How do you think about this proportion? Sorry, how do you think about this number? This number is smaller than 0.05. Then reject the non-hypothesis. So what is the non-hypothesis? We just mentioned the sample proportion, the depth, is the same as the population. But after our calculation, we found that the probability is very, very small, smaller than 5%. P-value is less than 0.05. There is enough evidence to show that proportion of death of Aboriginal prisoners is more than the non-Aboriginal prisoners. Okay, maybe something wrong in the prison. I don't know. I didn't know that. But this kind of calculation, maybe the Australian government should take care of those people. Maybe their death rate is abnormal. It's not usual. Okay, let's check this next question. Example 7.2 hypothesis step for the proportion using technology. Sure, later we will run this. A researcher who is studying the effect income levels in breastfeeding. Okay. I like this kind of example because I'm a father now. When my wife was pregnant, we always care about this kind of issue. Okay, that countries where the income level is low then have a higher rate of infant breastfeeding than higher income countries. And it is known that in Germany, considered a high income country by the World Bank, 22% of all babies are breastfed. In Tajikistan, okay, I think very close to the Middle East, considered a low-income country by the World Bank, researchers found that in the random samples of 500 new mothers, that 125 were breastfeeding their infant. At the 5% level of significance, does this show that in low-income countries have a higher incidence of breastfeeding? Okay, again, let's analyze the question again. Generally speaking, Germany is a high-income country. Sure, recently Germany has their own problems, but we don't discuss the problems. And now they think the high income study effect, the high income will change, although is low, have a high rate of infant breastfeeding than the high income countries. Okay, and generally, again, high income countries has lower, generally thinking, high income countries may be supposed to have lower breastfeeding rate, and low income countries supposed to be having higher breastfeed rate. Okay, let's move. State the random variable and the parameter in the words. Okay, that x equals the number of women who breastfeed in a low-income country, and the p, the proportion of women who breastfeed in a low-income country. And the hypothesis, non-hypothesis, their proportion is the same as 0.22 as the breastfeeding rate in Germany, 22%. The other alternative hypothesis, P is greater than 0.22 and set the alpha label at 0.05. Let's move. Question C. State and check assumption for a hypothesis test. And here, a sample random 500 breastfeeding habits of women. Sorry. Okay. Okay, and where the women in study, they consider they are identical, and though they probably have some differences, and there are only two outcomes. Either the woman breastfeeds there or they doesn't. The probability of a woman breastfeeding is probably not the same for each woman, but this is it is probably not very different from each woman. The condition for the binomial distribution are satisfied. Okay, and the question C. In this case, N, the sample number N, 500. Okay, and the P, 0.22. And let's calculate 500 times 0.22. Let me have the N times 0.22, that is 110. Thus, let's move back to the previous condition. Sorry, where is the formula? Oh, here, okay. And to determine the sample distribution of pH, you need to show that N, the sample number N times P, the proportion is equal to or greater than 5, and the N times Q, where Q is 1 minus P. If this requirement is true, then the sampling distribution of pH is well approximated by a normal curve. Okay, let's check whether this condition is satisfied or not. N times P greater or equal to 5, and N times Q greater than or equal to 5. Let's check it. Okay, 500 times 0.22, that is 110. That meets the criteria greater than or equal to 5. And let's check next. 500 times 1 minus 0.22, that is 390. 390 is also greater than 5. So the sampling distribution of pH is well approximated by a normal curve. And now we can move to the next. To this time, all calculations will be done with technology with this one. Sure, later I will give you some useful website. some is a website. And the error over the test is this one. Okay, we will skip this part because I will share different software with you. Once you press calculate, you will get the answer. And the Z in the results is the test statistic, and the P 0.052 blah 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 like this one is the p-value, and the p hat 0.25 is sample proportion, and the p-value is approximately 0.053. It's embarrassing. It's an embarrassing value. On R, the common is population test like this one. Okay, and one sample proportion test with continuity correction like this one. The sample P sample estimate P is 0.25, and get the p-value 0.5874. Okay. Now, since the p-value is more than 0.05, thus you cannot reject the H-non. You cannot reject H-non. And okay, the conclusion is very important because when I was a graduate student, we studied this one. After the calculation, we need to state there is not enough evidence to show that the proportion of women who breastfeeding in low-income countries is more than in high-income countries. Can you get the conclusion? But personally, previous we explained the type 1 error and type 2 errors. Type 1 errors and type 2 errors. There it depends on your proportion. Depends on your purpose. If you want to get a precise result, you can use one way. But if you, for example, I listened the podcast and YouTube channel. Some statistical experts explain like this: if some people go to the hospital and check in, have health exam, and they use very strict attitude to facing their exam results. And for example, according to some situational technology, they set alpha level close to 0.1. Why? Especially some cancer diagnosis. They don't want to make any mistake. They prefer to have a strict attitude, and if they got the cancer, they want to get a treatment as early as they can. Thus, they set the p-value as 0.1, not 0.05. Again, it depends on your purpose. As we used the example previously about a buyer go to a battery manufacturer to buy batteries, and the buyer suspect the report from the manufacturer about the using time, the life of the battery is a fake, is not true. Thus, the buyer tried to do the test and run a statistic, the results, and to determine whether he or she want to buy the batteries or not. Okay, and come back here. Personally, we know we set the breastfeeding. The p-value is 0.0574. But personally, we need to consider if we set the alpha level at 0.1. Yes, we can reject it. But this time, generally, we use 0.05. In this case, we fail to reject. No evidence or don't have enough evidence to show the proportion like this one. So far, is it okay? Sure. Next question, we will calculate this. And that's okay. Let me think about. Okay, how about let's try this one. Question number 6. In the year of 2008, there were 507 children in Arizona out of 32,000 who were diagnosed with autism spectrum disorder, ASD, autism development, the source of the information. Nationally, 1 in 88 children are diagnosed with ASD, like this one. Is there sufficient data to show that the incidence of ASD is more than Arizona than the nationally tested that at 1% level? 1% level. Okay, how about have a break and later we will come back to solve this problem. Okay, have 10-minute break. See you.